This is a pH box, so we can calculate pH or concentration using this pH box. So if we start off with the concentration, we can calculate what the pH is by going here this way. So the pH is just the minus log times the concentration of the hydrogen ions. If we have the pH and we want to see how much concentration of hydrogen ions we have, we use the anti-log minus the pH. And that will give us the concentration of hydrogen ions. And the same thing going this way, if we want to find out the pOH, we'll do the exact same thing. We have the concentration of OH, we want to find the pOH. We go this way to the right. We just take the minus the log of the OH. And on the right here, the pH just is 14 minus the pOH. Those are the easy subtraction problems. And vice versa, the pOH is 14 minus the pH. Now here we can, on this side, we can just calculate what the hydrogen ion concentration is if we're giving Kw and the concentration of hydroxide. And on this side, we can calculate the concentration of the hydroxide ions if we're given Kw and hydrogen ion concentration. Okay, let's find the pH of this problem here. So we know that pH equals minus log times the concentration of H plus. So we get the concentration of H plus. We have pH equals minus log of 1 times 10 to the minus 10. Let's bring up our calculator. And now all we have to do is plug this in. So we find our log. We go minus, oops, let me clear this from the last one, minus a log times 1e minus 10. So remember the E key, we enter it, and we get 10. Okay, so that's a pH of 10. So pH equals 10, and that's a basic solution. Okay, let's try the next one. pH equals minus log to the concentration times 1 times 10 to the minus 7. Let's clear this last one. So minus log, put E, second function E, 1 times 10 to the minus 10. Okay, let's try this. Minus log, second function E to the minus 7, 7. So I put E instead of just saying 1 times 10 to the minus 7 because it wasn't necessary. 1 times anything is itself. So we have a pH of 7. Now notice the similarities here. This is 7 and this is 10. If, and only if we have a 1 here, we just have to look at the exponent to get the pH. We don't have to plug anything into the calculator. All we have to do is look at the exponent, the positive value of the exponent, and that's our pH. As long as there's a 1 here. Let's try one that doesn't have a 1 there. 3 times 10 to the minus 2, so that's minus log times 3 times 10 to the minus 2. Let's bring up our calculator. So we have minus log 3 E minus 2, and that's 1.5. That's a 1.5. So that's a pH of 1.5. You can see it's close to a pH of 2, but it's not 2. Let's try the next one. 2 times 10 to the minus 7 minus log, and that's 2 times 10 to the minus 7 minus log 2 E minus 7 equals 6.69 or 6.7. So this is about 6.7. So we have, this is a basic solution, this is a neutral, this is acidic, and this is an acidic solution. Let's do the OH and OH concentrations now. We're going to go the other way. So if we have a pH of 3, what does that mean? Well, let's look at our, how do we figure that out? Let's look at our old formula here. pH equals minus log of H plus. So we're trying to find just the concentration here. And we're given this. we're trying to solve for this. So that means we have to take the antilog. So we're going to multiply. So what would that be? Let's look at what the antilog is on the calculator. So if we see here, if we look at where the log is, the antilog is right above it, the second function. It's 10 to the x. So we'll use that. It's just 10 to that power. So that means 3, it's going to be 10 to the third equals concentration of H. But we remember this negative sign, so it's 10 to the minus 3 will equal concentration of H. What would that be? Okay, second function, 10 to the minus third. We get 0.001. 0.001 is basically saying 1 times 10 to the minus 3, and that makes sense. That's a concentration of hydrogen ions if we have a pH of 3. Notice that's pretty easy, though. We can just go from 3 to 10 to the negative 3. There's a decimal, though. If it's like 3.12, we're going to have to change that around. We're going to actually have to put that into the calculator. Well, here's an example, 3.21. So let's put that in the calculator. Let's use this formula. So it's really 10 to the minus pH will equal the concentration of hydrogen ions. 10 to the minus 3 equals 10 to the minus 3.21 equals. So it's 10 to the minus 3.21. Second function here, minus 3.21. And we get a pH of a concentration of 6.17 times 10 to the minus 4. 6.17 times 10 to the minus 4. That is the concentration of hydrogen ions. Let's try something else. Ooh, POH of 3. A little different, but it's the same concept. POH equals a minus log of the concentration of OH. And it's the same thing. 10 to the minus POH will equal the hydroxide ion concentrations. And that is going to, we plug it in the calculator, that will also be 1 times 10 to the minus 3. What if we have PaOH of 9? This is a straight number. There's no decimal, so we can say the concentration of OH minus is 1 times 10 to the minus 9. Now, what is the hydrogen ion concentration here? For this last one, we can just, all we have to do, remember, they all have to add up to 1 times 10 to the minus 14. That must be 1 times 10 to the minus 5. It has to add up to 14. This one has to add up to 14, so that's 1 times 10 to the minus 11 for the hydrogen ion concentration. Number 2 is a little more difficult because we're going to have to take 10 to the minus 14 and subtract, or really divide, by 6.17 times 10 to the minus 4. So here we have 10 to the minus 14. Let's divide that by 6.17 e to the negative 4. We get 1.62 times 10 to the minus 11. The hydroxide ion concentration is 1.62 times 10 to the minus 11 moles per liter. So we have both the hydrogen ion and the hydroxide ion concentration here. And back up to 1. This is easy because negative 3, this is also just going to be this is the hydrogen ion concentration. The hydroxide ion concentration will add up to negative 14. So that's 1 times 10 to the minus 11 as well. All of these, when we multiply them together, should add up to 10 to the minus 14. So here we can see a table that has concentrations of hydrogen ions and concentration of hydroxide. And so we notice that the concentrations are exactly reversed. 10 to the minus, if there's a concentration of 1 here of hydrogen ions, there's a concentration of 10 to the minus 4th of hydroxide ions, so very, very, very small. So you can see how they just reverse. As we get decreasing acidity, we get increasing basicity.